This is the busiest shipping lane on Earth. Beneath these freezing waters lies one of the greatest engineering challenges ever attempted. This narrow stretch of sea separates Britain from mainland Europe, close enough to see, yet impossible to cross without ships. For more than 200 years, engineers dreamed of connecting these two shores beneath the sea. The earliest attempts relied on primitive tools, horses, oil lamps, and courage. Every time the sea forced them to stop. After repeated failure, Britain and France made a joint decision. This time, the project would move forward together. Construction began on both sides of the channel, from the cliffs of Dover in England and from the French coast near Sangatte. The success of the tunnel depended on one narrow layer of rock called chalk marl, strong, stable, and mostly watertight. Drill too high and seawater would rush in. Too low and soft clay would trap the machines. Precision was everything. On the English side, engineers blasted deep into the cliffs, removing hundreds of thousands of cubic meters of solid rock. As early as the 1800s, engineers stood on these shores, looking across the water, wondering if it was possible to connect the two lands beneath the sea. Each machine weighed nearly 1,000 tons. The cutter head alone was heavier than a commercial airplane. The geology was not the same on both sides. The British tunnels were relatively dry, while the French side faced looser, wetter ground. On the French side, sealed machines were required. Inside, temperatures could reach 50 degrees Celsius. A smaller service tunnel was driven first. Every meter acted as an early warning system for water leaks and ground movement. To stay within the chalk marl, engineers relied on gyroscopes and laser guidance, steering the machine with extraordinary accuracy. More than 7 million cubic meters of rock were removed. In England, the spoil was used to create entirely new land. Teams on opposite sides drilled blindly toward one another, separated by nearly 40 kilometers of rock. Any mistake would mean failure. The final alignment would decide whether the tunnel met or missed entirely. By late 1990, only meters of rock remained. After years underground, everything depended on this final approach. Two teams drilling blindly from opposite sides of the sea met underground for the first time. After 39 kilometers, the final alignment error was less than half a meter. Precision at an almost impossible scale. With the path confirmed, the two main rail tunnels followed, meeting beneath the sea in the months that followed. Some machines were too large to remove. Rather than waste time, engineers sealed them underground, entombed forever beneath the channel. In 1996, a fire broke out inside the tunnel. It was the ultimate test of the design. The service tunnel became a lifeline. Every life was saved. The system worked exactly as intended.